Something on a shallow level, Proxima Centauri D, which is one of the possibly reasonable exoplanets circling Alpha Centauri. One of the colossal reports actually was the disclosure of a planet that might end up being the nearest planet to us, Proxima B. The James Webb Space Telescope, the greatest and most impressive telescope at any point sent off into space, has been stretching the boundaries of room investigation for a really long time. NASA has been shipping off telescopes into space to reveal the privileged insights of the universe. However, none stand out in expectation as the James Webb Space Telescope. Regardless of its cosmic expense and broad deferrals, the JWST has been hailed as a distinct advantage in galactic perceptions, and presently it has made a startling revelation that has sent shockwaves through established researchers. The JWST has uncovered something that challenges how we might interpret the universe. Something so mind-bowing it's been named the Turn Air Pocket. Yet what precisely is a wind air pocket? What has the JWST found? And above all, would it be advisable for us to be concerned? Hold tight as we plunge into the enticing insider facts divulged by the state-of-the-art telescope, which could leave you doubting all that you assumed you had some awareness of the universe. The boundlessness of room holds vast miracles and secrets, from far-off worlds to baffling dark openings. As in animal categories, we are driven by interest, anxious to disentangle the mysteries of the universe both all over. Are there other keen creatures out there outperforming our own insight? Might there be a far-off exoplanet overflowing with life? Notwithstanding, the boundlessness of room presents an imposing obstruction to human examination, with distances that overpower the brain. Indeed, even the somewhat close red planet Mars requires a challenging excursion through the chilly profundities of room that requires over 5 months for volunteers of Elon Musk's colonization endeavor. And that is only the start. Envision needing to visit Proxima B, the nearest known exoplanet to Earth, found a stunning 4.24 light-years away. This means an unimaginable 25 trillion miles, an accomplishment that stays a simple dream with our ongoing technology. But does that stop our soul of revelation? Not the least bit. Regardless of the apparently inconceivable distances, we have tracked down brilliant ways of concentrating on these heavenly items from far off. Enter space telescopes, our strong eyes in the universe. While we will be unable to truly arrive at these far-off ponders, we can send our instruments to concentrate on them and open their insider facts, looking into the profundities of the universe from a distance. And as uncommon as the prestigious Hubble telescope is, NASA never neglects to stretch the boundaries of development, sending off satellites and tracking down better approaches to tackle the force of the universe's secrets, including the subtle idea of the wind drive. The JWST is a distinct advantage with unmatched capacities, permitting researchers to peer further back in time than at any other time to study the actual starting points of stars close to the snapshot of the universe's creation. With its phenomenal vision, it is multiple times more impressive than the Hubble, empowering us to dive further into the historical backdrop of the universe, arriving it back to inside 330 million years of the huge explosion itself. But how is the JWST ready to look billions of years into the past? The response lies in the excursion of light. As far-off starlight goes for billions of years lastly contacts us, the inestimable time container uncovers the mysteries of stars from a very long time back, from trillions of miles away. Despite the fact that a portion of these stars might have since a long time ago kicked the bucket, NASA has proactively disclosed an enticing rundown of the primary arrangement of pictures that will grandstand the spectacular capacities of the JWST. Among these spellbinding pictures is the Carina Cloud, a staggering heavenly haze of gas and residue that lies roughly 7,600 light-years from Earth, embellished with splendid stars that predominate our Sun in size. And afterward there's Stephan's Quintet, a hypnotizing universe bunch found great many light-years away, where 4 of the 5 worlds take part in a gigantic dance, their shapes misshaped by the gravitational powers of their enormous companions. But the wonder doesn't end there. The JWST has likewise caught stunning pictures of SMACS 0723, an interesting world group that twists and amplifies light from far-off objects behind it, permitting telescopes to recognize even the slightest and most far-off cosmic systems. This is where the JWST really sparkles, disentangling the secrets of the universe in manners already never imagined. However, in the midst of this multitude of unimaginable revelations, the idea of the wind air pocket looms not too far off, promising to change how we might interpret spacetime. In spite of the fact that digging into the intricacies of a Turn air pocket requires progressed numerical information, the ramifications of this momentous idea are totally staggering. So prepare yourself, as the JWST and its shocking capacities are ready to reshape our impression of the universe and open new wildernesses in our everlasting mission for knowledge. Now, envision riding through space on an air pocket where time and distance twist to your will. That is the brain-bowing idea of a turn air pocket. A pocket of contracted space at the front and extended space at the back, moving you forward at speeds surpassing the speed of light, all without disregarding the laws of physical science. It resembles a sci-fi dream workout. However, for what reason would it be a good idea for us to think often about contort air pockets? Indeed, they take care of a significant issue with quicker-than-light travel, time expansion. If you somehow happen to travel quicker than light, all that external your specialty would mature at a sped-up rate, while you could wind up going through years on a far-off planet with just hours passing for you, a disastrous result that could leave you expressing farewell to all that you loved prior to setting out on your excursion into the unknown. Twist air pockets are the stuff of quicker-than-light travel legends. Inside the air pocket, space stays unaltered, so time ticks ordinarily. An hour spent going at twist speed would be only an hour for every other person outside the air pocket. It resembles hitting quick forward on your fantastic experience without abandoning your friends and family. Enthusiasts of the famous Star Trip establishment are no aliens to the idea of twist travel. Across 10 television series and 13 Element films since its first episode in quite a while, have zoomed through the universe in strong starships, investigating far-off planets and speaking with extraterrestrial teams. At the center, all things considered, is the twist drive, a fantastical innovation that makes the incomprehensible conceivable. Since can we just be real, the universe is a marvelously tremendous and odd spot, with monstrous distances that make apparently difficult hindrances. In any case, with twist bubbles, we may very well have a method for navigating the stars at speeds once thought impossible. Now, we should investigate the slippery star Proxima Centauri, gleaming 4.5 light-years away in the huge enormous scope. Regardless of whether you could some way or another movement at the speed of light, it would in any case take you a stunning 4.5 years to arrive at that far-off star. In any case, tragically, light itself fills in as a definitive speed limiter, putting an enormous cap on how quick we can travel. Indeed, even with the quickest rocket at any point constructed, an excursion to Proxima Centauri would in any case require over 8,000 years, making remaining nearby Earth and its prompt area the functional decision. Nonetheless, the courageous team of the Star Trip universe didn't agree as far as possible. They tracked down an answer that resists customary physical science and considers really long travel in a negligible part of the time with the astonishing twist motor controlled by the surprising twist drive innovation. By twisting and bending spacetime, the twist drive can abbreviate the movement time to far-off stars, making for a thrilling and mind-bowing idea of travel. The thought of twist bubbles, proposed by visionary physicist Miguel Alcubierre in 1994, has changed how we might interpret interstellar travel. Envision compacting spacetime before your rocket and extending it behind you, making an air pocket of twisted reality that pushes you to your objective dangerously fast. This present reality suggestions are faltering. For example, with twist bubbles, an outing to Alpha Centauri, our nearest adjoining star framework, might actually be finished in only a month, as estimated by clocks on board the space apparatus and back in mission control. Remarkably, everything began with Alcubierre, a splendid psyche who was doing his PhD research on Einstein's overall hypothesis of relativity when he coincidentally found an episode of Star Journey, The Future. Motivated by the show's portrayal of monstrous items bowing reality, Alcubierre wrote down estimations on a piece of paper, establishing the groundwork for a weighty idea that shook mainstream researchers. In his visionary paper, Alcubierre illustrated compacting spacetime to make a twist bubble, an outrageous thought that might actually prepare for unprecedented conceivable outcomes in space travel. However, there's a trick with Alcubierre's twist bubble. The truth of making a twist motor is not even close to straightforward. You can't twist space forcefully with normal mass. You want something many refer to as colorful matter with negative gravity, a material that we haven't found at this point, making the practicality of twist drive sketchy. Alcubierre's thought is to encase a spaceship in an air pocket of level spacetime.